Hello and welcome to The Explainer. Today, we're going to dive into a really powerful technique that can make your software testing way faster and a whole lot more reliable. We're breaking down the key ideas from a tutorial that uses the Postman API tool. So, let's set the scene. Imagine you just built a new online ordering feature. Awesome. But now you have to test it, and not just once. You need to test it with tons of different products, different customer names, different scenarios. Doing that by hand over and over again, it's not just slow, you're bound to make a mistake. So how do you handle hundreds of variations without going crazy? Well, that question really brings us to this classic showdown. On one side, you've got manual testing. You know the drill, it's slow, it's tedious, and let's be honest, anytime a human is clicking the same buttons repeatedly, errors are going to happen. But on the other side, you have automated testing. It's lightning fast, perfectly repeatable, and it can scale up to handle a massive workload. The choice seems pretty obvious, right? But the real question is, how do you do it well? And this is where a much smarter solution comes into play. It's an elegant approach called data-driven testing, and it is absolutely key to unlocking real speed and reliability in how you test things. So what is it exactly? Well, data-driven testing is the simple but pretty brilliant idea of separating your test logic from your test data. Basically, you write one master test, just one, and then you feed it data from an outside file. Think of it like a spreadsheet. The test then runs automatically, once for every single row of data in that file. Let's break that down into 3 really simple steps. First, you get your data ready in a file. Every single row is a different test you want to run. Second, you create a single API request, but you use variables as placeholders instead of actual data. It's like a template. And finally, you just hit go, and the tool takes over, running that template for every single line in your data file. See? Simple, right? Now, to make this a little less abstract, we're going to walk through the example from our source material, a simple Books API. This will let us see exactly how data-driven testing works in a situation you might actually encounter. This Books API has a few key functions, but we're going to focus on 3 that create a really logical sequence. First, we have a post request to submit a new order. Then, a GET request to check that the order was actually created correctly. And finally, a delete request to clean everything up when we're done. Okay, now for the really cool part. Let's see how we actually connect those API requests to that external data file and build a completely automated flow. Now, this is the magic trick right here. Instead of putting a real book ID or a specific customer name into our request, we use these placeholders, these variables wrapped in double curly braces. This one little change transforms our API request into a reusable template. And you're probably wondering, okay, so where do the actual values for book ID and customer name come from? Well, they're pulled directly from that external data file when the test runs. This means adding a brand new test is as easy as just adding another row to your file. No new code needed. And here's what that data file actually looks like. It's just a simple CSV file, nothing fancy. You can see the columns book ID and customer name match our variables perfectly. So for the first test run, it'll use book ID 1 for John. The second time, it'll use book ID 3 for Kim, and so on, all the way down the list. Okay, let's follow that very first test run. The tool grabs the first row of data, that's book ID 1 and the name John, and sends it to the API to submit a new order. Just like that, a new order is created. Now, here's a really crucial part. When that order gets created, the API sends back a unique order ID. Our test script is smart enough to automatically grab that ID and save it for a moment. This technique, where the output of one API call becomes the input for the next one, is called API chaining. It's the glue that lets us build these realistic, multi-step tests. So, in step 2, the script immediately uses that order ID it just captured to make a second API call. This time, it's a GET request to fetch the details of the order we just created. This lets us confirm that, yes, everything was saved to the database exactly as we expected. And finally, step 3, the script uses that same order ID one last time, but now to delete the order. This is so important for good test hygiene. It means our system is left perfectly clean, exactly as it was before the test started, all ready for the next run. So we've seen the how. Now let's talk about the why. What's the real payoff for setting all of this up? Why does this approach win? The payoff really comes down to this single number: 5. This represents the 5 rows of data we had in our little test file, and it proves a huge point. What that number means is that the entire 3-step chain, submit, verify, and delete, ran from start to finish 5 separate times, once for each person in our file. And it all happened with a single click. Now just imagine if that file had 500 rows. The effort from you would be exactly the same. That's the power of this. So this brings us to the big benefits. First off, speed. You can run hundreds of complex tests in the time it would take you to do just a few by hand. Second, scale. Adding new tests doesn't mean writing more code. You just add a new row of data. Third, coverage. You can easily test all sorts of weird inputs and edge cases to find more bugs. And finally, you get reliability. Automation gets rid of human error, so you get results you can actually trust every single time. You know, by separating our data from our test logic, we've created a system that isn't just powerful, but it's also incredibly efficient and easy to maintain. It really makes you think, what's that repetitive, manual process in your own work that's just waiting to be automated?